We're going to now consider these homogeneous systems with complex eigenvalues. And you're going to find that it's very similar. Some of the techniques we use are going to be very similar to what we used back when we were dealing with second order differential equations that weren't systems, and how we handled it when we got complex numbers. So look here. Here we have a system of differential equations, linear homogeneous differential equations. And it's already in matrix form, so we just want to solve this thing. The approach we use is we find the eigenvalues. So 4 minus lambda here. So I just subtract lambda on the main diagonals and get the determinant. Okay, so I've got 4 minus lambda squared minus a negative 9. So here's my equation here. And if I work that out, I end up with lambda squared minus 8 lambda plus 25. Of course, using the quadratic formula, I end up with lambda equals 4 plus or minus 6i. Or plus or minus 3i. Sorry about that. Plus or minus 3i. Okay. Now, I'm going to take one of those eigenvalues. In fact, I'm going to take 4 plus 3i. And we're going to find that I'm not going to have to bother with the second eigenvalue. Because remember, what we're trying to do is we're trying to find we're trying to find a pair of solutions that are linearly independent. And we're going to be able to do that with the lambda equals 4 plus 3i. I don't need to worry about the conjugate here. You'll see as we go along. So now we've got the lambda equals 4 plus 3i, and I plug that back in A, and I get my system here. Negative 3i minus 3 minus 3i, and I've got K1 and K2. So what I'm trying to do is, of course, find this eigenvalue, or this eigenvector. I've got the eigenvalue, now I need the eigenvector. So I go through and multiply, okay? Like I'm going to solve a system of equations, but this is a dependent system. So I'm not going to be able to find one unique solution by elimination or substitution or anything like that. So remember, what I do is I maybe take K2 and solve it in terms of K1. And I get that K2 is equal to K1i. Okay? Now, at this point, what I can do is I can say, okay, I'm going to let K1 be negative 1. And there is the first of my there's the first entry in my eigenvector. Well, if K1 is negative 1, then what does that make K2? Well, that makes K2 just I. Okay. Okay. Now, I should probably start putting little arrows above here, so you'll distinguish the K's. I'm trying to, of course, these are lowercase k's and these are uppercase bold k's, but you can't tell. But what we have here is you have your eigenvector. Okay. Now, what I want to do with that is write a solution. So I can write this, right? Here you have it. This is the solution. Negative 1i e to the 4 plus 3i t. Okay? Now, remember, we're not happy with that. We want to write that using the trig functions. So, I'm going to take this e to the 4 plus 3i all times t, and I'm going to rewrite that this way. Okay? Okay. So notice the real parts up here, measuring parts here. So that's something that's familiar to you. Now the next thing I do, I'm not going to go to the next eigenvalue. I'm not going to go back up here to the 4 minus 3i. I'm just going to stick with this right here. And I'm going to try to get two independent solutions out of this. And here's the way I go. I go ahead and multiply this out. I multiply -1 times this, I times this, and get a new vector here. Okay? So all I did was multiply this through the eigenvector. And I got this. Now, notice I've got an I squared there, which is -1. And I've got an I here. And look what I've done. I've taken all the imaginary parts and I've put them over here in the second part, right? So I've got negative cosine 3t, real, and down here I've got negative sine 3t, and over here I've got the parts that have I associated with them, that have I multiplied by them. Okay? Now I'm going to split this up into two parts. I'm going to have the real part over here. Notice I just get two vectors out of this. I have this, which I put right here, and then the imaginary. And I'm just going to factor out the I there. So now we have these two things. We have this and this. Now, I've actually got two independent solutions there. What I'm going to do is this negative is going to be gone. I'm just going to replace it with C1. This I, it's going to be swallowed up in C2. So here's my general solution. C1 times this plus C2 times this. So this is one way to get two independent solutions. And notice I never had to go back and touch that 4 minus 3i. Now, let's look at another example here. Let's look at another example, but this time we're going to have an initial value problem. And I've got this system right here with this initial condition. So here I go. I go through here and I solve it like usual. I find my eigenvalue, 2 plus or minus 8i. Okay. I proceed as I always have. Okay. Plugging in the 2 plus 8i, 2 plus 8i, and I get this thing right here. Okay. Then I multiply and get my equations. I go ahead and multiply this out. 1 minus 8i k1 minus 13k2 and 5k1 plus the -1 minus 8i k2. Okay, so I get this. Now, here's what I'm going to do. As usual, I'm going to pick one of these equations and play my little game here. I solve for k1. Okay, so here is k1. Now, I've got a 5 down here. Hang on, it looks like this is 8i, and yeah, okay, I don't know what happened there. Okay, so now I've got this, okay, this right here, and I just need to let K2 be something. Well, the convenient thing to let K2 be, to get rid of this 5, would be a 5. So I'm going to let K2 be a 5, and if I let K2 be a 5, then K1 is equal to 1 plus 8i, because those 5s cancel out. Now, dig what I've got. I've got my eigenvector times this thing. Now I'm going to do the same thing, multiply this through these things, and I get this. Now, and dig that I've got an I squared there, so that's going to be a -1. I take all the real parts and put them in this matrix over here, this vector. I take all the imaginary parts and put them in this one over here. And, if you do that, this is what you get. So there is my solution. There's my general solution. Now, What I want to do now is address the initial condition. It says that x sub 0 is 3, negative 10. Okay, so that's what I want to deal with now. So here I go. I'm going to put in the 0. Okay, so I'll put in the 0 in for t, and this first vector over here just becomes 1 over 5, 1, 5. So I have 1, 5, C1, and then this next one becomes 8, 0, because sine of 0 is 0. So I just get 0 in the second row. And we're told that that has to equal this 3, negative 10 vector. So I say, well, that means that C1 plus 8C2, C1 plus 8C2 equals 3. And 5C plus 0C2 equals negative 10. Well, there you go. So that means that C1 is negative 2, and then if you work that out, you get that C2 is 5/8. And lo and behold, you have your final solution here. See? There's your negative 2 right there. And in place of C2, you got 5/8. So that's the way you deal with the initial condition. And once again, notice, we didn't even care about 2 minus 8i. We never addressed that. All we needed was our two solutions. Now, there's different ways, like I say, to approach these problems. I use this method, and the book offers you a couple of different methods. On page 344, they give a particular formula for finding the two independent solutions. But this one works.